In the top structure, we have a positive charge, so we want to move electrons towards it in order to stabilize it. We could start by moving this pi bond over here to the positive charge. Which would give us our double bond on the right here. Now this carbon here we've moved electrons away from without replacing them, so that carbon is now going to have a positive charge. There's another resonance structure that's possible as well. We could take these electrons here and move them down and push these electrons back to where they started. That would give us this structure here, which has a positive charge on the oxygen. You'll notice that this structure is the exact same that we would have gotten if in our first move, instead of moving the pi bond towards the positive charge, we just simply moved these electrons down to the positive charge. So that leads to this structure on the far right, the red arrow. For the second one, again, we have a positive charge and we want to move electrons towards it to stabilize it. So I'm going to take the electrons from this pi bond, break them, and move them towards the positively charged nitrogen. That gives us our first resonance structure, which looks like this. We've moved electrons away from this carbon here, so it's now going to bear the positive charge. Now we want to keep moving down the line, moving electrons towards our positive charge, so I'll pop this pi bond over towards the positive charge. Now it may appear as if we're finished with pi bonds, but this nitrogen, as a neutral nitrogen, has 5 electrons associated with it, which means that there's a lone pair here. And so we can use that lone pair yet to stabilize this positive charge to make our final major contributing resonance structure, which looks like this. And has a positive charge on this nitrogen. For the lower molecule, again, we have a positive charge, so we want to move electrons towards it to stabilize it. I'm going to start by moving this pi bond over here. The result will be that this central carbon here now has a positive charge since we've moved electrons away from it. Now we can keep pushing electrons towards that positive charge, and we'll end up with this structure, which will put the positive charge on the end. Alternatively, when we got to this middle structure here, we could have taken these electrons and pushed them down towards the positive charge. That would give us the same resonance structure as what I am about to do here, which is where I'm going to put these electrons down and at the same time move this pi bond back to where it came from. So I'm doing that just so that it's a linear sequence, but you could also write that structure coming off of this middle one here. So now this oxygen just has one lone pair left. Its other one's been used up in the pi bond, so it's only got 1, 2, 3, 4, 5 electrons associated with it, so it is bearing the positive charge, and that's the final resonance structure there.